This is a story of the production age, a half-century of amazing developments in mass manufacture, reaching a zenith under the urgency of war, and now holding sweeping post-war opportunities for even greater production efficiency and cost economy. But I'm getting ahead of my story. How many of us can remember the day this early vintage car first scorched down the road at the terrific speed of 15 miles per hour? That was in 1898. A little before I started out into the world on my own. The advertising literature described it as the supreme engineering achievement in horseless carriages, the acme and perfection, which it was doubtful anyone could ever surpass. On the other hand, skeptics said that the automobile was a passing fancy, soon to be forgotten. A few devilish young bucks with more money than was good for them bought the new contraptions and sallied forth to charm the debutantes of that year, and incidentally to scare self-respecting horses half to death. This was the same year that a little machine shop was started in the shadow of the budding automotive enterprises in Detroit, a business that was to parallel in engineering development the growth of this first mass production industry. Established by Milton O. Cross and his father, Charles W. Cross, this company began building what is believed to be the first valve and head gas engine. But in this gas-lighted era of the automotive industry, practically all Detroit shops were drawn into production of some needed parts for the assembled cars of the age. Cross, being gear specialists, among other things, became a major supplier. There were transmissions to build, steering gears, timing gears, and axle differentials. And how well I remember driving some of those old Cross-equipped cars. Chevrolet was one of them, and Page, and Henry Ford's Model T. Then others were the Saxon, Columbia, Liberty, and Scripps Booth. Wonder what ever happened to them. And when I was in Italy during World War I remember riding in a cross-gear-equipped Fiat. I thought I was a long way from home, but I was still in Detroit's backyard. To form all these gears, Cross engineering genius had been called upon to design and produce superior machinery for tooth rounding or chamfering. The results were so admired by all gear users that an immediate market of great proportions was available for these new basic tools, carrying them into almost every civilized nation in the world. That was the beginning of the envied Cross reputation for the designing and building of special machines for industry. During the boom years that followed, their engineering eyes looked farther afield to the many machining operations that could be similarly served by an unusual knowledge of intricate motions and timing and methods of improving accuracy and efficiency in metal cutting. Machines that would be push-button operated, machines that would perform any one or a series of operations simultaneously or in program sequence. Machines that would be built around the requirements of a part, rather than attempting to adapt a number of standard tools to its manufacturing needs. Machines that would apply the automaticity of a screw machine to the production of any part and any series of metal cutting operations. Process machine tools. Here in the minds and on the drawing boards of this forward-thinking machine tool builder, the means for an entire new era in manufacturing began taking form. Then came World War II. Cross, like other key plants in our production picture, temporarily set aside projected developments for consumer manufacture and fell wholeheartedly into the production of the needed tools to fashion the machines of war. Tools built for the greatest production job of all time. To Cross fell a task which would prove their ability to back their engineering talent with manufacturing facilities equal to, probably, the greatest peacetime demands that would ever be placed upon them. The task of supplying shell-turning lathes to equip 14 great plants in the war effort, from Pennsylvania and New Jersey in the east to Missouri, Michigan, Wisconsin, and Minnesota in the Middle West, and Alabama and Texas in the south. Time was the essence of the contract. Cross engineers were ready with the machine designs that would rough and finish turn shells like these at tremendous speed. Multiple tool machines that would hog off metal chips 1 1/4 inch thick and rough turn this 240 millimeter shell, for instance, in minutes instead of hours. Finish turning in a correspondingly short time. this gigantic order, numbering hundreds of lathes, was delivered on time to provide the shell manufacturing capacity which played so big a part in shortening the war. Want to buy a shell lathe? Of course you don't. We all hope their need will ever continue to diminish. But let's look at some of these remarkable lathes on which the battle of production was won, making possible final victory in the field. Let's see what stuff these tools are made of and picture from their performance the production to be expected from machine tools of the future. Cross machines performed several operations in shell production, including centering and cutting off of the open end of the rough forging, rough turning, facing the closed end, and forming the pith boss, that little handle left on for convenience in handling, and finally, finish turning after the nosing operation. Here we see the centering and cutting off operations on 155 millimeter shell rough forgings. There goes one of them on its way, and the cut-off section is disposed of. Next, notice how simple it is, even for this girl, to handle these heavy forgings from conveyor to position. And the machine loads itself and starts the cut at the touch of a button. This close-up shows the cutting tool digging deep to slice off this tough steel forging to size for its next ride through the rough turning lathe. Simultaneously, on the closed end, the forging is centered for the turning lathe's tail stalk. Notice the irregularity of this forging as it revolves, and you will understand the importance of this operation. But we have just started. Let's get on to the rough turning lathes that these machines are feeding in this mad pace for greater and greater production. As I walk down this line of cross-roughing lathes that seem to go on and on into infinity, listen to the shriek of the cutting tools and smell the unmistakable odor of hot oil vapor hanging in the atmosphere, I really knew I was in an arsenal of democracy. Yes, these cross machines are record holders in rate of metal removal. Let's watch one of them turning a big 240 millimeter forging. There it goes, and down come 8 tools to hog off the metal in 3/4 inch chips. That forging weighed approximately 540 pounds when it went on this machine. It will weigh about 384 pounds when it leaves the machine 6.5 minutes later. Boy, that is certainly losing weight, 25 pounds a minute. But let's get along to the finish turning lathes that are equally ambidextrous. These machines are really big brutes. They have to be to handle these 240 millimeter shells. By the way, those fellows are not loafing. They're waiting for their cross-automatic machines to complete their cycle. And they will be on the job pronto to reload and push the button that sends them on their way. No sooner said than done. There's a lathe stopping now, and its attendant is on the spot. When war manpower was scarce, the fact that one man could attend more than one of these lathes spread our productive efforts to multiply our nation's output. Now here's a neat trick to save turning time. Watch these cutting tools feeding toward the left. 2 tools are cutting, but one bides its time. You will see it later. Now with the coolant shut off, notice that 3rd tool I drew your attention to, coming down to cut the burlay on the right-hand feet. In other words, this machine catches them coming and going. And so we leave shell making, an industry we hope will be dormant for many years to come. But we leave it with the consciousness that the cross-tool building facilities demonstrated here, coupled with unique vision and designing skill, has a real significance post-war-wise, offers the promise of a new technique that will greatly affect our business economy. Production at a push of a button. the technique that enhances human skill and multiplies its effectiveness, eliminating an economic bottleneck in production at a profit. I have traveled recently through Burma and India, China, and the Near East, where human toil is the cheapest thing in the world. And I have visited the great plants of the industrialized Western nations, where I saw the wonders of an economic system that has lifted the working man to an estate where he may enjoy more of the luxuries of life than an Eastern potentate. But in all my travels, I have never before seen machines that so multiply man's skill in respect to value of work accomplished as do these process machine tools. Looking at a few of these process machine tools makes it easy to understand just how radically different they are from the old operational tools of the past. Here, progressive gauging, drilling, countersinking, and tapping operations are performed to finish a truck axle housing with 14 holes in 3 different planes. This line drawing shows the problem, and the following sequence shows how it is accomplished, again entirely automatically, at the push of a button. As you watch it go through its paces, remember, this machine finishes 6 of these axle housings per hour at 80% efficiency to save its owner $46,900 the first year, while completely amortizing the investment. There's that push button, and the job starts on its way to the second station, where holes are drilled in bowl face and side. This machine replaces 10 conventional machine tools, saves 935 square feet of floor space, reduces the piece cost nearly $5 each. Now to the counter drilling station. This close-up shows the tool arrangement for drilling and tapping different size housings. And finally, to Station 4 for tapping the 14 holes. Job completed, we go back for another housing. While we're looking at drilling and tapping, here is another excellent example of major savings. Take, for example, these diesel engine cylinder blocks, which require 5 angular holes to be drilled and tapped. Cross designed the machine to do this job. Automatically picked up from the conveyor, these blocks are loaded, located, clamped in the machine. The 5 holes shown are drilled and tapped. The block is ejected and returned to the conveyor at the rate of 45 per hour with 80% efficiency without being touched by human hands. The machine is completely push-button operated. And here's the economic score for this machine over previous operational machine tools required to turn out the same production. A saving of 15 machines and 255 square feet of floor space. An investment of $8,975 less. And a cost per piece, including amortization of equipment the first year, of 48 cents less, representing a total annual saving of $86,400. Who can resist this invitation to profit? Or perhaps your problem is precision boring, or taper thread milling, or precision facing, or all three, as in the case of this large manufacturer of heat-treated alloy steel oil tool joints. This cross-process machine tool accomplishes the results indicated in this drawing in programmed sequence. Two of these machines finish 16 oil tool joints per hour, do the work of 10 conventional tools, require 22,000 square feet less space. They will save their owners more than $100,000 the first year, in addition to complete amortization of their investment. This man is locating and clamping the work in the holding fixture with a dial indicator. From here on, the work is automatically indexed to all stations. Let's watch it go to work. $100,000 is not chicken feed in any manufacturing plant, and I thrilled to the timed motion, sequence, and precision that made these economies possible. Indexing to the first station, the piece is precision taper bored, and the 1/32nd radius is formed. Now the machine indexes the work to the rear head for rough and finish taper thread milling. All of these operations are still completely automatic, depending only upon the robot mind and hands of the machine for accomplishment. Here we see the finished thread milling of 6 pitch Acme threads, 3/8 taper per foot, that must be concentric with the bore within 4/1000 total indicator reading. That's nice, accurate work in any man's language. And now, to precision face the bottom shoulder and radius, and the job is done. A miracle in metal cutting, performed by a metal mind that cannot err, get tired, or wander off on thoughts of fun, fishing, or family trouble. A result always the same, in always the same time, just as a constant speed motor spins on its merry way. Assured quality, precision, production cost, and profit. That is the promise of the process machine tool. Speaking of precision, production, and profit, here's another one for the book. Post-war wheel hubs will have 2 hardened integral taper bearings automatically processed on cross special machines to 3 micro-inches. These bearings will replace the separate bearing cups shown here. Aside from the great savings in eliminating the separate bearing cups, these machines offer the following machining economies over conventional operational machine tool production. At the production of 50 per hour, one process machine saves 3 conventional machine tools, more than $6,000 in tool investment. It reduces the cost per piece to less than 1/3 and nets the first year, after complete amortization of the cross machine, a total of over $22,000. This 3-station machine is shown here being loaded at one station, while rough and finish grinding takes place on both ends of the hub at the second station, and honing to 3 micro-inch finish on both bearing faces is accomplished simultaneously at the third station. Notice the work requires only a single chucking in a self-indexing trunnion-type workhead. This single chucking not only saves handling time and labor, but guarantees absolute concentricity of finish bearings. Another interesting feature of this process machine tool is the automatic dressing of the wheel between the rough and finish grinding operation. Watch the almost human action of this machine as the grinding heads rapidly advance to the work, settle down to the prescribed cutting speed, rapidly retract for dressing of the wheels, rush back to the finished grinding operation, and retract again at high speed to clear all spindles for indexing. All this while, the honing heads are working away in like manner and timed in coordination as though a whole squad of invisible traffic cops were directing them. Like all self-respecting individuals, this machine washes its face before each bite at the work. And that's automatic too. Grinding finished, all particles of metal and abrasive are flushed clear of the work before the high precision honing begins. Since this washing is done while the work is being indexed, more split seconds are saved too. There it goes on its way, taking off a 1/3 saving on each of the 50 wheel hub bearings it finishes each hour. So it goes, and from what I have seen of cross-process machine tools in key spots in the production lines of many of our post-war industries, and the amazing economies they are effecting in the manufacture of innumerable parts for the kaleidoscope of products so vitally needed by a war-starved world, I agree with the editors. These process machine tools are truly the answer to a new prosperity for both industry and labor, not to forget greater value for John Q. Public, who after all pays the freight for all of us. It was with this interest that I visited the Cross plant in Detroit recently to see something of how these miracles in metal are conceived. Just how, if I were a manufacturer of something more than hay on my Dutchess County farm and yarns for books and radio, these engineers would approach my machining problem. Obviously, it was impossible to witness all the stages in the development of a machine around the metal removal problem of a particular part at one time. So the Cross organization offered to demonstrate the major steps which led up to this mighty machine nearing completion on the assembly floor. Started in this little huddle of men in a conference room, poring over a part which some doubtless had never seen before. This oil drill cutter that goes down into the earth's innards to tap our priceless petroleum resources. Questions of tolerances, production requirements, metallurgy, and so forth began popping about my head. Then the conversation got completely over my depth in higher mathematics. But I noticed all these men making notes continuously, and finally they broke up with a definite assignment arranged for each in working out machine motions, timing, powering, production flow, automatic controls, tooling, and last but not least, the economics of the proposed method of machining, preparatory to meeting again and again to merge their ideas and facts into a preliminary design. And now plans and specifications are ready to go off to the customer for his approval, not with just a price quotation, but with a complete comparative analysis of the cost of producing this piece with the cross-process machine recommended as opposed to conventional operational machine tools. Just for fun, let's look at the score for this machine. It must be a good one, for it sold the machine. And it certainly is, as you can see for yourself. Savings of 9 machines, over 900 square feet of floor space, more than half the cost of the finished part, in machining 40 of these oil drill cutters per hour. No wonder they bought it. Next stop, the shops. I was as anxious as I know you are to witness this idea that we have seen take form on paper actually blossom into a live and working machine. So let's watch some of the operations being performed on the almost countless parts, large and small, that go together to make up this great machine. Precision begets precision, so these highly skilled craftsmen work to infinitesimal fractions of an inch. Talk about thousands as though they were a matter of feet. With all their respect for little things, however, these men swing castings weighing tons. They swing them about like bales of hay and assemble them with a nicety that belies their girth and weight. Soon the other units will slip into place like pieces in a giant jigsaw puzzle, and we will see the machine go to work. Incidentally, these shops are a show place of order, cleanliness, and efficiency, even in such a city of great industries as Detroit. To my mind, they represent the fourth of the 4 outstanding qualifications which the Cross Company offers, justifying their reputation for leadership in the spatial machinery field. These 4 qualifications are: vision, to foresee the profitable application of process machine tools and to project their advantages in terms of hard, cold, economic facts. Experience in building special machines, in developing intricate motions and timing, in applying automatic controls and devices. Designing skill, to combine wide and varied experience to produce machines capable of simultaneous and programmed operations built around the requirements of any product. Facilities, capable of supplying the special machine requirements of any manufacturer. And now, as you watch this cold steel incarnation of the fragile fabric of an idea go to work for the first time to advance our industrial progress another notch, I'll say so long and thanks for a most interesting preview of things to come in a new manufacturing world.